What does the derivative tell us? In this video, we're going to look at an application on the population of China to see what the derivative tells us about the situation. So let's go ahead and read the problem. If t is the number of years since 2014, the population of China in billions can be approximated by this function. We're going to estimate f of 6 and f prime of 6 giving units. What do these two numbers tell us about the population of China? This little 8 here, I pasted, this is a problem from our book, by the way. At the bottom, it tells us where this problem came from. Here's the website. So they modeled this problem from the real data. So it's a real life problem. Okay, so what is f of 6? So f of 6, I'm just going to plug a 6 into my formula. I'm going to use my calculator. So I'm just going to put this in y1, since I'm going to be using it again for part B. And then I'm going to go to table set. Make sure the independent is at ask. And then I'm going to go to table, which is above the graph. I'm just going to type in 6. And we get about 1.4. And since t is the number of years since 2014, and p is in billions, p is actually the population of China in billions, this tells us that there is 1.4 billion, there was 1.4 billion people. The population was 1.4 billion 6 years after 2014. So they projected from this formula that in 2020, which is actually now, the population should be about 1.4 billion. Since it is 2020, right now I decided to look it up. Our book was the last, they came up with this in 2014. The last copyright of our book was 2017. And look at how accurate they were. So this is a population live now, and 2020 is the last bit of data. And there it is. 1 billion, 1.4 billion, 1 billion, 440 million people. Okay, what about the derivative? What is f prime of 6? Well, we first have to estimate it. So we can use our new formula. F of 6 plus h minus f of 6 over h. And we can do this for specific values of h. Or we can do it in general. So I'm just going to do it in general. So this is 6 plus h into my formula. And then 6, we already found this to be about 1.4. But I'm going to do something different. I'm going to put in my calculator just like this, so that way it does not get rounded incorrectly. And you do not have to do it this way. You could actually find values here and subtract them and divide by small values here. But I'm going to go ahead and put it all into my calculator at once. So I'm going to put this into parentheses first, right parentheses for the numerator. And then I'm going to type in that whole numerator there. Type all of that in, the 6 plus the x minus the next values. Oops. And then I'm going to end the parentheses, and I'm going to divide by that h, so x. So there it all is. It doesn't all show here, but it's there. And then I'm going to go to table again. It's already on ask. I'm going to go to table set just to make sure. I'm going to go to table, and I'm going to type in small values for h. So because we're looking at the limit as that h goes to 0. So maybe 0.1. 0.01, and continue on. And you can see that it's going to the same value as I get smaller. This right here means 1 times 10 to the negative 4. So it means if you move that 1 4 place to the left, it's 0.0001. So I decided to put this whole thing in my y1, so it just gives me the answer. But you could do it in steps. You could put the regular function in y1 and then subtract that 1.4 and then divides by small values and then do it halfway. Okay, so we say this is approximately equal to, right, about 0.00864 is the answer to that derivative. We don't know if it's exact or not. It looks pretty good, but since we're dealing with decimals here, I'm not exactly sure. So I'll go ahead and just keep it as approximate. And they did say to estimate. So there it is. What does that mean? With our new notation, we know that it's the dp over dt, since the y is p and the x is t. And that is going to be then billions per year. So the units of this is 0.00864 billion per year. That is going to be the rate of change, how much it's going to increase each year, the population. So that's kind of a weird looking number. So I'm going to change this to millions, because what does 0.00864 billion even mean? 1 billion is like 10 to the 9. It has 9 zeros. So this is like saying 8,640,000, right? And that would be the rate of change of the population each year, right at t equals 6, which was since 2014, so it was 2020. So in 2020, the population is growing at a rate of 8,640,000 people per year. You can also say this another way. We could say that for each year, like in 2020, we're going to increase, every year, we're going to increase about 8.6 million people. That's another way of saying it. So we've answered all the questions. Here it is. Here's the original problem. Make it a little bit smaller so we can see everything. They asked to estimate the function and the derivative, and what did these two numbers tell us about that population? Hope this helps.